Hi guys, welcome to Easy Math.
In this video, we are going to discuss about the simplex method to solve the linear programming problem. Linear programming problem is denoted as LPP. Okay. First, we have to solve the type 1. Here you have to note the 3 points. First, the objective function is of maximization type. And second, all the given constraints are of less than or equal to type. All the given constraints are of less than or equal to type. Third one, all variables are non-negative. That means all variables are positive. First problem, use simplex method to solve the following LPP. Maximum z is equal to 4x1 plus 10x2 subject to 2x1 plus x2 less than or equal to 50, 2x1 plus 5x2 less than or equal to 100, 2x1 plus 3x2 less than or equal to 90 and x1, x2 greater than or equal to 0. Here this is the objective function. It is of maximum type, that is maximization type. These are the constraints. Here the constraints are all less than or equal to type, and this is the variables which are all non-negative. Okay. For maximization problem, we did not bother about anything, just proceed with the simplex method. Here the constraints are all of less than or equal to type. Therefore, you have to introduce slack variables. Okay, for the first constraint you have to introduce the slack variable s1, and for the second one you have to introduce the variable s2, and for the third one you have to introduce the slack variable s3 to write it as the inequality form. Now we have to write the standard form of the given LPP. In the objective function, the slack variables cost are 0. Therefore, 0 s1 plus 0 s2 plus 0 s3. And subject to the constraint, first constraint you are introducing the slack variable s1. Therefore, it is s1 plus 0 s2 plus 0 s3. Whenever we are introducing the slack variable, the cost must be 1 and the cost of the other slack variables must be 0 for that corresponding constraint, okay, which is equal to 50. By introducing the slack variable, you are converting that inequality into the equality format. Here 0 s1 plus s2 plus 0 s3 is equal to 100, and this one is 0 s1 plus 0 s2 plus s3 is equal to 90, and x1, x2 and s1, s2, s3 are all greater than or equal to 0. Here this x1 and x2 are non-basic variables and s1, s2, s3 are basic variables. Okay. First, after completing the standard form, you have to proceed with the initial basic feasible solution. How you get the initial basic feasible solution? By substituting the non-basic variables as 0. By substituting the value of the non-basic variables as 0, we get the initial basic feasible solution by using these 3 constraints. Okay. First one, s1 is equal to 50, second one s2 is equal to 100, and third one s3 is equal to 90. These are the initial basic feasible solution. By using this initial basic feasible solution, first you have to proceed with the initial iteration table. Okay. This initial iteration table, first you have to remember the notations we are using here. This is CB. This is the cost for the variables you are introducing. In the first initial iteration table, the initial basic feasible solutions are here. That means the variables, slack variables s1, s2, s3 are here. Its corresponding cost should be written here. And this is the XB. XB means the right hand side values. Okay. You have to write all the variables used in this problem, that is x1, x2, s1, s2, s3. And you have to find the ratio. Here you have to find the value of Zj minus Cj. Let us discuss one by one. Here you are writing the Cj. This denotes the cost of the variables in the objective function. Cost of the variables in the objective function. What is the objective function? Maximum z is equal to 4x1 plus 10x2 plus 0s1 plus 0s2 plus 0s3, right? Therefore, the cost for the variable x1 is 4 and the cost for the variable x2 is 10 and the cost for the variables s1 and s2 and s3 are zeros. Okay, this is the Cj values. Always you have to remember that first you have to write the initial basic feasible solutions. What are the initial basic feasible solution? S1 is equal to 50, S2 is equal to 100 and S3 is equal to 90. Okay. The cost for the slack variables in the objective functions are 0, 0 and 0. Therefore, S1 value cost is 0 and S2 cost is 0 and S3 cost is 0. Now, first you have to write the coefficient of the variables in the three constraints. Okay. In the first constraint, what are the coefficients? 2 for x1, 1 for x2, 1 for s1, 0 for s2 and 0 for s3. And for the second constraint, what are the variables? What are coefficients corresponding to the variables are 2, 5, 0, 1 and 0. And for the last constraint, you have to write the corresponding coefficients, that is 2, 3, 0, 0 and 1. Okay. Now we have to find the Zj minus Cj value. How we are going to find means, we have to multiply this cost with the xb value, 0 into 50 plus 0 into 100 plus 0 into 90. The value is 0. Okay. Here minus Cj, there is no Cj values here. Therefore, simply you have to find the Zj values. And for the x1 variable, 0 into 2 plus 0 into 2 plus 0 into 2, that is 0, minus the Cj, that is minus 4. And for the x2 variable, 0 into 1 plus 0 into 5 plus 0 into 3, that is 0, minus 10, that is you are writing here minus 10. And for the s1 value, 0 into 1 plus 0 into 0 plus 0 into 0, that is 0, minus 0, again you are getting 0. Next, for the s2 variable, 0 into 0 plus 0 into 1 plus 0 into 0, that is 0, minus 0 is 0. Next, for the last variable, that is s3, 0 into 0 plus 0 into 0 plus 0 into 1, minus 0 is 0. Okay. Now you have to choose the most negative value. We have to choose the most negative value. Which is the most negative value? This minus 10 is the most negative. Most negative value means it is the least value. Okay. You have to choose the most negative value among the Zj minus Cj values. Here, this is the most negative value, that is minus 10. Therefore, this is the pivot column. This is the pivot column. Okay. Therefore, x2 is the entering variable. x2 is the entering variable. This column is the pivot column. This column is the pivot column and the entering variable is x2. If one variable enter in the iteration table, then one variable should exit from this. Okay, that means one should leave from this iteration table. For that only we are going to find this ratio. How we have to find the ratio means, you have to divide this xb column by this pivot column. Okay, that is 50 by 1, that is 50 t, 100 by 5, that is 20, 90 by 3, that is 30. That means you have to find the ratio by dividing the xb column with the corresponding pivot column element. Okay, corresponding pivot column element. Then among these values, among these ratios, you have to choose the minimum positive value. That is, you have to choose the minimum value. What is the minimum value here? 20. Therefore, this S2 variable leaves the iteration table. Okay, this S2 leaves the iteration table. Therefore, you have to encircle this row, and this is the pivot row. Okay. Now this element, that is 5, is the pivot element. What is the pivot element here? Pivot element is 5. The leaving variable here is S2. If all the Zj minus Cj values are greater than or equal to 0 means, if all the values must greater than or equal to 0 means, then you stop here and you find the optimal solution in this iteration itself. Otherwise, if Zj minus Cj value is less than 0 means, or at least one of the Zj minus Cj value is less than 0 means, you have to proceed to the next iteration by finding this pivot element. Okay. Here the entering variable is x2 and the leaving variable is s2 and the pivot element is 5. By using these three terms, you have to proceed on to the next iteration table. You have to find the first iteration table. This first iteration table can be calculated by using the initial iteration table. Okay. Here the entering variable is x2 and the leaving variable is s2. Therefore, in the first iteration table, you have to replace this s2 by that x2, s2 by this x2, and the remaining s1 and s3 variables are as it is. Therefore, there is no change in that. Write the variables s1 and s3 as it is. That means we are going to use one formula here. Now we have to calculate the new s1, x2 and x3 values by using the row calculation. What is that means? In this first row, in the first initial iteration table, we are considering this as R1 and the second row as R2 and third is a R3. And a similar case, we are taking the first iteration variables S1 as R1 dash, second row as R2 dash and third as R3 dash. Okay. Always remember that you have to find the entering variable first. Okay. You have to find the row R2 dash. That is R2 divided by the pivot element. R2 divided by the pivot element. What is the pivot element here? 5 is the pivot element. Therefore, R2 divided by 5. Okay. What are the coefficients here? 100 divided by 5, 2 divided by 5, 5 divided by 5, 0 divided by 5, 1 divided by 5 and 0 divided by 5. Okay. What is the value? Here 100 divided by 5 is 20. 2 by 5 is 2 by 5. Always you have to remember that you have to maintain the fraction in the iteration table. Okay. 5 divided by 5 is 1. 0 divided by 5 is 0. 1 divided by 5 is 1 by 5. 0 divided by 5 is 0. This is the new R2 dash. Now we are going to find the R1 dash and R3 dash. New R1 dash is equal to old R1 minus the corresponding pivot column element. What is the column element? Corresponding value 1 into new R2 dash. New R2 dash. Okay. What is that? R1 dash is equal to R1, that is old equation, minus the corresponding column coefficient, that is pivot column already we find, no, that corresponding column coefficient into new R2 dash, that is the new pivot equation. Okay, what is that? R1 old value is 50, 2, 1, 1, 0, 0, and 1 into R2 dash. What is R2 dash? 22 by 5, 1. Therefore, 1 into 20, 20. 1 into 2 by 5, 2 by 5. 1 into 1, 1. 1 into 0, 0. 1 into 1 by 5, 1 by 5. 1 into 0, 0. Okay, you have to subtract this term. 50 minus 20, 30. 2 minus 2 by 5, 8 by 5. 1 minus 1, 0. 1 minus 0, 1. 0 minus 1 by 5 minus 1 by 5. 0 minus 0, 0. You have to write the values in the corresponding S1. Similar way, you have to find the R3 dash value. What is the R3 dash? R3 dash means old R3, that is R3 value minus its corresponding column coefficient, that is 3 into R2 dash. Okay. What is the R3 value, old one? That is 90, 2, 3, 0, 0, 1. And 3 into R2 dash. 3 into 20, 60. 3 into 2 by 5, 6 by 5. 3 into 1, 3. 3 into 0, 0. 3 into 1 by 5, 3 by 5. 3 into 0, 0. You have to subtract these two equations. 90 minus 60, 30. 2 minus 6 by 5, 4 by 5. 3 minus 3, 0. 0 minus 0, 0. 0 minus 3 by 5, minus 3 by 5. 1 minus 0, 1. Therefore, this is the new R3 dash value. Now, we have to write the values. Already we find. What are the values? R1 dash is 30, 8 by 5, 0, 1, minus 1 by 5, 0. And R3 dash is 30, 4 by 5, 0, 0, minus 3 by 5. Okay. Now, you have to write the cost values. What is the cost of S1? There is no change in that cost. That is, you have to write this from the objective function, right? That is 0. What is the cost of X2? 10. What is the cost of S3? 0. Now, we have to find the Zj minus Cj value. Okay. Zj minus Cj means 0 into 30 plus 10 into 20 plus 0 into 30. What is the value? 10 into 20? 200. Next, 0 into 8 by 5? 0 plus 10 into 2 by 5? 4 plus 0 into 4 by 5? Again 0. 4 minus 4? 0. Okay. Next, 0 into 0? 0. 10 into 1? 10 plus 0 into 0? 0 minus 10. 10 minus 10? 0. Okay. Next one. 0 into 1? 0. 10 into 0? 0 plus 0 into 0? 0 minus 0. The value is 0. Next. 0 into minus 1 by 5? 0. 10 into 1 by 5? That is 2. 0 into minus 3 by 5, that is 0. Therefore, the value is 2 minus 0, that is 2. Next, 0 into 0, 0. 10 into 0, 0. 0 into 1, 0. Minus 0, the value is 0. Here, look at this. All Zj minus Cj values are greater than or equal to 0. All values of Zj minus Cj are z greater than or equal to 0. Therefore, this solution is the optimal solution. Hence, the optimal solution is obtained. Okay, the optimal solution is given by x2 is equal to 20 and maximum z is equal to 200. Here there is no x1 value is obtained, right? Therefore, the x1 value is equal to 0. Okay.
Thank you for watching. Don't forget to like, share and subscribe. Bye guys.